2018-55-59 Cahit Barkın Özer, Çukurova Üniversitesi Bilgisayar Mühendisliği 3. sınıfım. You can see my output here, FCFS schedules the processes in request order. As you can see, SJF schedules the processes in length of task, and RR uses time quantum. So we have a fixed time quantum. We give it to the algorithm. It's 10 unit. So if our process time is over 10 units, it works for 10 units, and then goes to the end of the queue at that moment, and then it repeats this process until all of them works and finishes. So priority scheduling is based on priorities. They are given priorities, and priority RR schedules tasks in priority, and if their priority are equal, it schedules them for RR. So let me show you my code. FCFS, we have our libraries here. We have a node pointer, which is null. This one inserts the null, gives its initial values, and inserts it. Pick next task, it finds the task where name first comes first, and as you can see, it gives the best to the first name comes first one, and deletes the node from list, and the task will get deleted, and schedule function runs the scheduling. We create a task in type of task and send pick next task to it, and if task exists, run and then free the name, and then task goes to the pick next task. And SJF, this part is same, and here it's same, but we add a new task to the list of tasks, and in here this one inserts the new task into the list of tasks. If its temporary is not null, temporary is heads next. If it's not null, it checks their burst times and returns the head pointer afterwards, and then schedule does the scheduling. If its head is not null, task goes to takes the pick next task and then runs and then deletes. And we have RR here. RR, this one is same, but we have current pointer. Current pointer, we use it for sending at the end of the queue. In order to delete the current node, if the task completed, so if current next is null, current will be head. If current else, current will be current next. It moves, and temporary tasks burst. If equal, it deletes it. Reverse list. Reversed it at the beginning of the schedule. If temporary is not null, it inserts, and then head will be reverse head. In here, if head is not null, current task will be current task, and then slice. So here, quantum, if quantum is equal or smaller or equal than the current task's burst, it will be a quantum, slice will be quantum, or else it will be current task's burst, and then it runs, and then it's minus the slice time, so we have the remaining time from the task's time. We have its remaining time. In priority, this part is same. This is, it checks if their priority are equal, then looks for the name, or if temporary is priority bigger than the best priority, best going to be temporary's priority, and then deletes it and returns the best. This one schedules, as you can see, it's obvious. Priority RR. So priority RR, as you know, turnaround time is equal to burst time plus waiting time. So we have head, null, and temp, and count. Count is the amount of process with the same priority, and head is empty, so we place the node at the end of the list, since head is at the end, and node not at the end of the list. We keep looking for it by traversing. Afterwards, in here we have pick next task in not the same priority and also bigger, so reset to 1, and here not same priority, so we increment it. And in schedule, if it's the amount of process with the same priority bigger than 1, we do this, and if it's not, we run as normal. If it's bigger than 1, we look if current burst is bigger than quantum, like round robin, and then do our scheduling. Else, if it's not bigger than the quantum, we just do it without minusing the quantum. That's all. Thank you for listening.